So let's begin with doubly and circular. First thing is appending, depending on the doubly. So there will be two cases. Case one is the DLL is empty, and case two is if the DLL is not empty. And first thing is if temp equals to none. If this thing happens, then put the looks and you one range but data is equal to 1 but 3 is equals to null pointer and this is also null pointer. Then the previous assigning previous defined that one has not get that. Okay, fine, it's a D node. Then R is equal to Q. Q equals to R. This might work. Margins just traverse at the end of the loop while m dot list not equal to then m equal to okay, and then okay, connect the keyboard. So now temp is pointer to the end and then to the top. And there will be two pointers, yes. This was dot frame equals to q and then fine. This was appending at the end of the bucket list. Now let's say the add at the beginning. Now how can this be done? The same case. If the linked list is empty, And let's say if it's not empty, then what can we do? The doubly linked list is not empty. The linked list is not empty. Mm, if it is not empty, then I have to add at the beginning. Okay, first of all, let's just assign the MD and the data, the malloc function, and then uh, next is equal to 10 and 10 the previous pointer will go to R and then 10 will point to R, or the Q will point to R. Mostly is that is what happens here. R dot edit and R dot trace is none. Mm, okay, directly use star Q and also use star Q thing. Stretch node. It is a D node, not node. Yes, 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 yes. Fine. And then Q will be pointing just be equal to R. Is the added beginning function, I guess. Okay, fine. And now then add after by writing this function by struct for the case one and then R. Then is equal to Q. For R adapter, single pointer is sufficient, I guess. Same thing. And then now what will I do is by okay, this is where I iterate location and if temp dot is equal to if temp is equal to none, then I guess this condition will be here. and then we simply print this. Okay, now else what will I be doing is we are going to use our drawing app to demonstrate this thing. This is our doubly list. States kind of like this thing. Let's say I want to add after this now. How will I be adding is I have this thing. Now there are double connections here. Now what I need to do is I need to join this here, join this here, and join these both here as well. Fine. This is my aim. How can this be done? Mm, What I need to do is this thing. Then first of all I'll find the space. Because I have made no errors here. So I have written D node instead of D node that would be a huge. Now what will be doing is dot data is equal to the number which I want to store, and r dot next is equal to r dot data is the number which I want to store. R dot r next is equal to next, and then next is equal to r. Struct node has no field previous. What is the struct node here? I have declared all of them as double node, I guess. Hmm. Struct node has no field previous, but I guess I have declared everything as a double node. What is struct node? Define that continue. Temp next is this node. That previous will be pointing to R. Now temp next will be pointing to R as well, and R will be pointing to. I don't know why I'm facing error here. The struct node has no field. Which looks off. Hmm. There's a problem in data structure declaration. Now it might work. Yeah. Hmm. So this is temp, and this is now first point is temp next previous is will point to R, and R next will be pointing to temp. Fine. This is done, and on this side, temp next will be pointing to R, and R previous will be pointing to temp. I feel so. Yes, that's the thing which is happening here. Insert new node. Q is equal to Q square. Okay. Data, and then mm, previous. Right. Okay. Okay. Here we have R as R previous equals to temp, and then R next is equal to temp next, and then R next previous is equal to R. R next previous is equal to R. R next is equal to Q next is equal to temp previous. Where is it going? To Q. Fine. And Q next. Where is it going? To temp. Fine. Q next previous is going to temp. That is also fine. And then Q next. Yeah, I guess mine is somewhat okay. Okay. Both are the same. I feel any error will be facing in future. Then I will come back and debug it. Now moving to the next one. Add offense, then display the doubly linked list, and then count the number of nodes, then delete the specified node, and then we'll move to circular linked list. Then after that, stacks and queues implementation. For that, I need to go for the prefix and postfix operations. Now, next is display the doubly linked list. This is the declaration. Now, Yes, 2D doesn't matter. Anyway, I'll just print it. 2 dancing places. And then uh, it's the delete function. Now what do I need to include in the delete function is q is the starting one and a number pointer obviously and then not location but the number which I need to delete. Now this is somewhat, let's say if no, first of all, I need to create a temp, but I don't know why I declare this as node. It's always the D node. Now what do I need to do is this data is equal to the number whatever it I have found it created it. Let's say and the data is none. I have found it and there will be two conditions. If it's an empty linked list, let's say if it's the first node actually, and I just need to set q equal to and use the memory and then return it. But let's say that's not the case here. Is what I need to do is temp is equal to temp and then wait. If I have encountered this thing which I need to delete, I need to maintain a struct old as well here. And then what I'll need to do is, let's say this is the node which I need to delete. This is the node which I need to delete, and this is old, and this is let's say temp. Okay, fine. Now what I need to do is old This link should be done as old dot next is equal to, and then old. So this pointer reassignment is being done like this, and this thing will be done like this. Old next is equal to temp next, and temp next previous is equal to points to the old pointer, and then I can happily clear memory and make this fine. I think that's it. Oh no, I lost the page. Sorting a linked list. Where is that double linked list? This is circular linked list, and I need to implement both stacks and queues as well. This is I'm sorting a linked list, merging, and there is doubly linked list. Pointers and data structures, merging options. I need to look it up. I guess this is the doubly linked list. The delete function is d underscore delete. Okay, I think he didn't maintain, he maintained a single pointer. So if it is the first one, or else we can just do the same thing. What I think this will be none as well. This is also a null pointer, and moreover, this is also a null pointer. Previous one is also a null pointer, next one is also a null pointer. Wait, I need to delete it. Okay, got it. It's not a null pointer always. Temp is q, and then q is equal to q next. It will point to the next one, and q previous is null. Fine. And nothing is to be freed here. Else, if it is last node or any intermediate node, okay, use the single pointer here. Outside the while loop, he just use q next. If it's the last node and if it's the intermediate node, it's the okay, this is the thing which is done. And he just create the temp empty without using the old pointer. I think in single linked list it cannot. It, it might be not, it might not be possible to do this. Let's check this one. And then we go to circular linked list because I need to go in this assignment. Lab 5 okay. This one is to create a circular linked list, and this is to create a doubly linked list. Ask it to remove duplicates. Node of the working logic or not. 8446. 846. Okay, fine. This can be done easily. All we have to just check is the if the element has frequency greater than 2, I'll remove that element from the W linked list. And then moving to this thing, the nodes can provide an at runtime given a W linked list as risk to reverse the W linked list without using any extra list. Render using head pointer before and after using the list. Okay, fine, I can write the function for this thing. And this is just creating a tail pointer which is pointing to the head pointer. And for this, I need to work with the stacks and queues. Okay, fine. Let's try this. My aim is to use a single pointer. First of all, let's say it's a null pointer. What I mean is temp next is equal to null. This is the last element which I need to delete. Then what I just need to do is create temp. But wait, I think is this sufficient actually? But, and then what I need to do is temp previous next will be set to null. Okay, fine. I think that's it. And let's say it's not the last linkage which I need to delete. Else what I'll need to do single pointer again. This is temp. If I the figure is too dirty actually, don't mind about it. Temp, this is what I need to delete. So temp next previous will this is the temp next. So the previous pointer will be pointing to temp previous. Temp next previous will be pointing to the previous. Okay. And then same thing will be happening here. Temp previous next will be pointing to temp. With autocorrect saved. And then just return it. So there's no need to write return again explicitly. And I need to return. So just to be done before the return function. And then again, return. Return is when we have this. And this is where I need to keep on iterating. Temp is equal to temp next and then enter. If it is not found, not found. Okay. Now we are done with the W link list. This was what I forgot actually. This is the interesting part actually. And W link list is how do we delete in W link list? First, I need to check whether it's the first node which is to be deleted, and then next thing I'll check is it the last node which is to be deleted, or else is it an intermediate node which I need to delete. In single linked list, it can be done simply with first I need to verify the command for if it's the last node to be deleted. Temp is equal to null. Okay, yeah, it's correct. Kind of correct. Yesterday I have been doing both statements. Okay, next one is if the statement is found. Okay, Circular linkage. Pointer data structures, merging of linked list, linked list polynomial, sorting, very circular. Okay, this is where front and where, okay, now we have to go with the circular linked list. The primary operations like delete, adding. Yeah, I guess that is enough. Those two operations are enough for circular linked list. And just modify this thing to make it look beautiful. I didn't ask this. Yeah, I guess this will be fine. Where does the thing go which I copied? Yeah, this is best, I feel. So the first function is the append, and then second is the add at beginning, and the third function is the add after, and the display, and then the count, and what else? The delete. Okay, now going to circular list. See what functions I need to add. Is circular, fine. Now into the functions, leave it. Now I think node is sufficient for this thing. I need to create two nodes now, which is the rear node and the front node, I believe. Okay. Front and rear null. Front rear. After circular, we have the postfix and stack expression. I need to look for that as well. There's a implementation of stacks as well. First of all, I need to remember the page for this thing. Page 166. So I need to study for this exam. Mm, There is the stacks and queues implementation. Nothing of linked lists. Yeah, this is stacks and queues. I was in 10 minutes. Pop and push. Pop, push, stack display, and count. That's it. And in queue, there is something like display, DQ, delete the element from the queue, add the element to the queue. NQ and DQ operations basically. Okay, fine. Now, let's begin with the circular linked list. First one is add circular. Add circular. Now, what is being done here? Let's analyze. Queue malloc, okay. Queue data is item, if the queue is empty, f equals to null, f is equal to q is r. If the queue is empty, how do I add element in circle linked list? That's what I need to analyze. Hmm. This is the circular linked list where I'm having this type of nodes. Okay, now they are connected. The layer is connected to this thing, and this is how they are connected. Now I need to add at the end of the queue. This is where I need to add. Now the name will be something of this thing, and I need to create this connection between them. How can this be done? Is let's leave the empty case, or else rear pointer I'm passing to it. Link equals to q, r equals to q, and then r link again it will be go to the front node. Okay, if it is empty queue, then the forward will be going to queue as well, and r is equal to q, forward is equal to q, and r it will be pointing to itself if it's an empty case, and then removes an element and displays the whole queue. I think the assignment had its operations. I can just take it. Write a create circle inclusion nodes where each node value of the net instance node as integer value declaration. Create a node where node number is given as input, print the list before and okay, node number is given as input, print the list before and after deletion. And how is this done? Doubly linked list where user block value of an at runtime, each node has integer value. Task is to reverse the W linked list. Okay, fine. Reverse can also be done. The reversal is quite simple, I believe. Now let's go with this thing. First of all, let us look at other functions which are defined. delete circular link list. So now what I need to do is remove this. So the new bond will be like this kind of. So what is being done is if the queue is empty, queue is empty. If F is R, it means there is only a single element. Then what is being done here is item is equal to F data. Okay, F is equal to null, R is equal to null. Then what is item doing actually? Return item. Okay, that is Q or circular linked list. That is circular linked list. This is stack and Q. Anyways, I'm not interested in returning anything. And what I need to do is if it's F equals to R, then I just create. Else Q is equal to F. I need to iterate it like this. From the front of the queue. Okay, I need to write the function for this. I'm not interested in deleting front of the queue. Or else delete the node. Q is equal to F. Item is equal to Q data. F is equal to F. Okay, delete this node, let's say. So Q is pointing to this thing. If F is equal to R, then delete the node. Delete this node. Q is equal to F. Item is equal to F is equal to F dot link. Link is equal to F. Read Q. Okay, I will look at this function later. And displaying is also, I'll just look at it later. Adding at the end of the queue or appending, let's say. Or let's make it a C append. I'll make sure to save all the files, or else it will be fine. Save. Now, what will be passing is but not head node and back node. Gray node. I will replace queue with the head node actually. Uh, yeah, now it looks fine. And temp is also fine. Anyways, now if F is null, first of all, I need the number to be added as well. what number I need to happen. Okay, I need to just hmm. Now I need to add it to the end of the circular linked list. Let's say the linked list is empty. Then what will I be doing is okay, no sneak peek. If it's an empty linked list, then how will I add it? Then what I need to do is uh, f is equal to 10, and then r dot next will go to f. I guess that's the thing. It's done. F is equal to null, f is equal to 10, and then I also need to do this. The rear point is nothing but temp here as well. Else, uh, what will happen in the else cases? What will happen in the else case? If it is none, then I'll just do this thing. Else, if f is not none, if f is not none, what will I do? I'll be assigning to a temporary pointer and then is equal to temp and next is equal to print, right? And then return. This is what is being done. Now I just need to add them here. Void as append. What are all the functions they have created? I need to add all the definitions. The append, then add at beginning, then add after. Need to add the semicolon as well, and then display, and then count, and then delete, and yeah, let's start to the next. Okay. Uh, Where do I need to write double linked list? Double linked list. Okay. Now we are done with defining the libraries. Fine. And I think I can now easily implement these lab functions. Also, I need to check the other way assignment. And data structures, labs, and then batch B, then lab IB. Let's see this thing. Like an offline. So then, okay then. Bye.